Very good morning to all of you. So I cordially welcome you all for this engineering thermodynamics course. So in the today's classroom discussion topic, so let us discuss about the four important topics. So the first one is the heat engine, the working principle, heat pump working principle, refrigerator working principle, and the fourth one is the relationship between the COP of the heat pump and the COP of the refrigerator. So why we have to study all these things? So that is what is the motivation? So it is essential to know that how a heat engine, heat pump and refrigerator will work according to the second law of thermodynamics. So the outcome of the today's lecture is after completion of this lecture, you should be able to draw the schematic diagrams of the heat engine, refrigerator and heat pump. And similarly, you should be able to derive relationship among efficiency of a heat engine, COP of the heat pump and the COP of refrigerator. So with this intention, we are going ahead with this lecture. And in the previous class, already we studied about the Kelvin-Planck statement. That is, the Kelvin-Planck statement says that the heat engine will work or heat engine will produce some amount of the work whenever it is operating with minimum two thermal energy reservoirs. One is the source and one is the sink. And similarly, the Clausius statement says that heat transfer always takes place from the higher temperature body to lower temperature body. If you want to travel the lower temperature body to the higher temperature body, always we have to give some amount of the work input, then only it will work. So the performance of the heat engine, that is how can you evaluate the performance of the heat engine? Because you know that what is the basic function of the heat engine? The heat engine, it is a device which is used to produce the maximum work transfer from a given positive heat transfer. That is by taking some amount of the heat input, it is basically converting it into the maximum amount of the work. So how can you measure the performance of the heat engine? So the performance will be measured in terms of the thermal efficiency. So thermal efficiency is nothing but, normally efficiency is nothing but output by input. So in this particular case, the thermal efficiency is the work done by heat supplied. So work done is denoted by W and the heat supplied to the heat engine is Q1. So W by Q1, that is the performance of the heat engine is normally expressed by the efficiency. Next, coming to the next one, that is the refrigerator and similarly the heat pump. The refrigerator heat pump performance will be evaluated by means of the coefficient of performance. Coefficient of performance, which is normally denoted by COP. So how can we define the COP? So COP is nothing but is a desired effect divided by work input. Desired effect divided by work input. Normally, most of the students will define COP in such a way that it is a refrigeration effect by work done. So there is no work done. There is no work done in the refrigerator as well as in the heat pump. So always in the denominator, you have to say it is a work input. Work input to drive the refrigerator or work input to drive the heat pump in case of a heat pump. So don't say work done. So it is a work input. So I'm saying that in the generally, the COP is nothing but is a desired effect divided by work input. So in case of a refrigerator, desired effect is the refrigeration effect or the cooling effect. That is nothing but Q2. So Q2 amount of the heat is taken from the evaporator. So the cooling effect which is obtained here is the Q2. So Q2 by W, that is the COP of a refrigerator. And similarly, whenever you are talking about the heat pump, so what is the basic function of the heat pump? The heat pump is basically used to produce the heating effect. So normally where you find the applications of the heat pump means whenever you are residing in the cold countries or in the cold areas. So normally you can go for the heat pump. So that is the surrounding temperatures are very, very low and we have to heat that particular the air with the help of the heat pump and we have to supply the heated air or the warm air to the required place. So in this particular heat pump, the COP is defined as desired effect by work input. So here the desired effect is the heating effect. Here the desired effect is the cooling effect and here it is the heating effect. So Q1 by W. So Q1 is nothing but Q1 amount of the heat is added to the required amount of the space. So Q1 by W. So it is the COP of the heat pump. So here you can say, so that is the Q2 amount of the heat is taken from the cold reservoir, that is the evaporator. So that is Q2 by W. In case of the heat pump, the Q1 is added to the hot space, that is the room where you are living. So that is the hot reservoir. So it is our efficiency W by Q1 in case of the heat engine. So refrigerator COP Q2 by W, heat pump COP Q1 by the W. So the same thing, the thermal efficiency of the heat engine is the Q1 minus Q2 by Q1, COP of the refrigerator, Q2 by W. W is nothing but difference of two heat transfers, Q2 by Q1 minus Q2. COP of the heat pump is equivalent to Q1 by Q1 minus Q2. So here you are able to say that COP of the heat pump is always greater than the COP of the refrigerator, because the COP of the heat pump, it is equivalent to 1 plus COP of the refrigerator. So whenever you are having 1 plus COP of the refrigerator, so we can say that COP of the heat pump is always greater than the COP of the refrigerator by unity. And also here you can see the efficiency of the reversible heat engine, because normally the heat engine or refrigerator or heat pump will work according to the irreversible process. But sometimes he can say that the heat engine is operating on the Carnot cycle. So you know that the Carnot cycle is basically consisting of all four reversible processes, like two reversible isothermal process and two reversible adiabatic process. So all four reversible processes are there in the Carnot cycle. Then you can write down the Q1 minus Q2 by Q1 is equivalent to T1 minus T2 by T1 for a reversible heat engine. And similarly for a reversible refrigerator which is operating on the Carnot cycle, also you can write down is a T2 by T1 minus T2. So similarly for the heat pump also you can write down T1 by T1 minus T2. So whenever you are comparing these two equations, so we are able to write down the COP of the heat pump is always equivalent to is a 1 plus COP of the refrigerator. That is a one important relationship between the heat pump and refrigerator. And whenever you are comparing the heat pump COP value and similarly the heat engine efficiency value, just you are able to see it is the T1 minus T2 by T1 and here it is a T1 by T1 minus T2. So both are reciprocal with each other. So that's why we can say that the efficiency of the heat engine is equivalent to 1 by COP of the heat pump. Efficiency of the heat pump is nothing but 1 by the T1 by T1 minus T2, that is nothing but 1 by COP of the heat pump. So these are the very, very important relationships. That is the second outcome. So the first one is the relationship between the refrigerator and COP, that is the COP of the heat pump is equivalent to 1 plus COP of the refrigerator. That is the T1 by T1 minus T2 can be written as 1 plus T2 by T1 minus T2. So T2 by T1 minus T2 is nothing but COP of the refrigerator. So 1 plus COP is equivalent to COP of the heat pump. Similarly, efficiency of the heat engine is the T1 minus T2 by T1 can be written as 1 by T1 by T1 minus T2, that is 1 by COP of the heat pump. So these are the very, very important relationships between the heat pump and refrigerator COP and COP of the heat pump and efficiency of the heat engine. So with these important concepts, several questions were asked based on this particular one. So let us see one problem on these important concepts. So a heat engine receives heat at the rate of 1500 kilojoules per minute. So Q1 is 1500 kilojoules per minute. Gives an output of 8.2 kilowatts. So W is equivalent to 8.2. Determine thermal efficiency. So you know that thermal efficiency is nothing but W by Q1. So W has given 8.2 kilowatts. Then Q1 he has given as 1800 kilojoules per minute, because I always saying that here the units are watts and here it is a kilojoules per minute. Always you have to check the units. Watt is nothing but joule per second. So it is a kilojoule per second, but whereas it is kilojoules per minute. So if you substitute directly 1500 without any conversion, then automatically it will lead to wrong result. So that's why always you have to check the units. So always units will be in the same fashion. So convert kilojoules per minute into kilowatts or kilojoules per second, 1500 by 60. So now thermal efficiency you got it as 32.8 percentage. And what is the rate of heat rejection? because he is asking the Q2 value. So you know that W is equivalent to Q1 minus Q2. So you know Q1 and W, substitute the values, you are able to get Q2 is equivalent to 16.8 kilojoules per second or kilowatts. So similarly, going to the second question, find the COP and heat transfer rate in the condenser of a refrigerator in kilojoules per hour, which has a refrigeration capacity of 12,000 kilojoules per hour when the power input is 0.75 kilowatts. So here also kilojoules per hour is there. So convert into the kilojoules per second. So that is hour multiplied with 3600. So you are able to get the power input. Input is nothing but 0.75 kilowatts. And you know that COP of the refrigerator is always equivalent to Q2 by W. So Q2 value just you calculated. So W, so substitutes, you are able to get COP is equivalent to 4.44. And is asking us about the heat transfer rate, how much amount of the heat is supplied to the condenser. So W is equivalent to Q1 minus Q2. So Q1 is equivalent to Q2 plus W. So find out, so what is the value of the Q1? So it is equivalent to 14,700 kilojoules per hour. So like this, we are able to solve some problems on the important relationships between the thermodynamics important fundamentals, that is the relationship between the heat engine efficiency and COP of the heat pump, and similarly the COP of the refrigerator and the COP of the heat pump relationship. We are able to solve such type of the problems in the GATE examination and similarly in the university examinations. So I hope you understand the concepts very clearly. We will meet you once again in the next classroom discussion topic. Thank you very much for attending this class.